Okay, let's do prime factorization using the TI-36X Pro. Okay, first thing you need to know is prime numbers. They go 2, 3, 5, 7, 11, 13, 17, 19, 23, and they keep going. We really don't know how far. The only even number that's prime is 2. Everything else is odd. Now, the cool thing about prime numbers, you can't break them down with other numbers. 5 can't be broken down into two other numbers. For example, 6. 6 can be broken down into 2 times 3. And 6 is composed of prime numbers. And thus 6 is not a prime number. 6 is a composite number. The prime numbers is defined as is divisible by itself or 1. And 2 is the only one that's even. So, for example, if you wanted to know what's the prime factorization, 10 is a composite number, but how is it broken down into primes? Pretty straightforward. You start using these numbers to break it down. This ends in 0. We know that 2 goes into 10 very easily, so we can say 10 divided by 2, it gives you an answer of 5. So 10 is broken down into 2 times 5, and that's the answer. Let's say 50, right? It ends with 0, and I know 2 goes into 50, so 50 divided by 2 gives you 25. It ends with 5. Does 3 go into 25? No. So you have 25 divided by 3, right? 8.33. No, it's not. But we know that 25 divided by 5 will go into it, right? 5 will go into 25 5 times. So 50 is equal to 2.5 times 5. 50 is a composite number. It's broken down into primes. It can be rewritten as 5 times 5 squared, just as a shortcut. Now, in class, you might see 50 being broken down through tree, and then this is 2 times 50, no, 2 times 25, I'm sorry. 2 times 25 gives you 50, and then this breaks down into 5 times 5, and then you look at your prime numbers, and then you can write it out. I don't like doing the tree because sometimes I forget the numbers. It doesn't also show me, like in this upside down bracket, that here at the end, I have the last number should be a prime number. Okay, all right, let's clear that. Let's do 350. I know 2 goes into 350 because it ends up at 0, so 350 divided by 2 gives you 175. Can you say 5 goes into 350? Yes, you can. But it's always good to start with the small one, small numbers first, small prime numbers first. 175, it ends up with 5, so we're going to divide by 5, right? 5 divided by 175 is 35. We know that 5 goes into, and here I could just say divide by the previous answer, divide by 5. It's going to give me 7. Okay, so 350 is equal to 2 times 5 squared times 7. Now, why do prime factorizations? Well, let's say you had 50 divided by 350. You can use prime factorization to reduce. Well, let's see. 2 times 5 divided by 2 times 5 times 5 times 7. 2's, the 5's, the 5's, that's a 1. 1 over 7. Nice, right? If you do it here, we have the fraction button. And then 50, bring it down, 350, enter, 1 over 7. Very straightforward, very nice. Okay, now let's do 101. Okay, 101 turns out to be prime. Okay, 101. Very hard to know if it is, right? Question is, what you could have done is 2 goes into 101, 3 goes into 101, 5 goes into 101. The thing is, eventually, if you knew all your prime numbers, you would have said, oh, 101 does go into 101 once, and it's a prime number. That's how, question is, how far can you go to reassure yourself that you can stop at some prime number? Well, if you take 101 and take the square root, right? And the square root of 101. This calculator, what you can do is you can go there, you can enter, you can put a period here, it gives you a number, okay? 10.049, approximately 11 is the next, you round it up. So 2, 3, 5, 7, 11. If none of these go into it, then we know this is a prime number. We know it is, but let's try it anyway. 101 divided by 2, no. 101 divided by 3, no. What do I mean no? It doesn't go evenly, nicely. 101 divided by 5, I know that doesn't work. 101 divided by what? 7, no. 101 divided by 11, no. So this is prime number. Okay. Okay. Let's try 51. Some of you might say, 51, prime number, done. Doesn't look like anything will go into it, right? But here's a trick. Sometimes you can add the digits. This will give you 6. Does 3 go into 6? Yes. So that means 3 does go into 51. Oh, it does? Yep. 51 divided by 3 is 17. Okay. So 51 is equal to 3 times 17. Now you can take 51, take the square root of 51, right? So take the square root of 51. And again, I forgot. Put a period. Which is equal to 7.14, which is the next prime number up is 11. So again, 2, 3, 5, 7, 11. Use any of these numbers into 51, and we found out that 3 goes into it nicely. So just be aware of that. Prime factorization has other things also that you can use. You can use it for factoring, quadratics, finding the lowest common denominator and such. There's a lot of things. So I hope you like this video. Please give it a thumbs up. Please subscribe. Please tell your friends. Please tell your teachers that these videos are up here. All right, I'll see you later. Bye-bye.